Okay, so in this video, we're going to be going over solving equations using logarithms. Now, we've saw what to do when we have the same base, right? But what is going to happen when we have something like this, 3x plus 1, all right? Okay, all right, so now in this case, all right, what we have here is we have 2 to the x equals 3 to the x plus 1. All right. Now, there's no way like I had in the previous video, right, where we had the 25 and we were able to write it as 5 squared and then we had the same base. Can't do that here, right? So we had to take a different approach, right? There's no way to rewrite this here as the same base. So instead, what we're going to do is we're going to take the log of both sides. It doesn't matter which log you can take, any base. It really is unimportant, right? It actually winds up with the same result, right? Which is a nice, nice property of these logarithms. So I'm just going to write log. We'll assume it's the common logarithm. Well, not assume, it is the common logarithm base 10. All right, so I'm going to take log of both sides of the equation here. Right, and again, here we're using the one-to-one property of these logarithms, right, where we can just do this. Right, not just the exponentials, but the logarithm is also one-to-one. And then from here, I'm going to use the properties of logarithms, right? Those are going to come into play here, right? So here, I'll use the power, log 2, x plus 1, log 3. Okay? All right. And now it's very similar to when we just had linear equations when we're trying to solve for x, where I want to isolate the x on one side of the equation and everything else on the other. All right, we just have logs involved, but the process is still the same. Right, so the first step in doing that is what I'm going to do here is I'm going to distribute this x or log 3 into x and then that plus 1. So this would be x log 3 plus 1 times log 3. Right, so we just use our distributive property right here. Okay, and now I have an x here, I have an x right here. So on the other side of the equal sign, so let me go ahead and move it over by subtracting x log 3 to both sides of the equation. All right, so I'm going to subtract x log 3. Okay, so these are not the same term, right? Remember, in order to think of the log 2 is just a number, right? So you can think of it like a coefficient, right? So if they were, they had to be exactly the same. They are not here. So for right now, what I'll do is I would just rewrite this as x minus, excuse me, let's do that again. X log 2 minus x log 3. And here that goes to 0. And on this side, we're just left with 1 times log 3 or simply log 3. All right, so we're getting there, right? Since step by step here, right? Well, take it slow here. What I notice now here is they have a common factor of x. So I'm going to factor that x, and that leaves me with this quantity here. Okay. All right. Now here I'm going to use properties of logs. This is the quotient rule, right? When I have log 2 minus log 3, this is actually the same thing as log of 2/3. All right. And now what I'll do from here, I'm almost there, right? This is going to get divided by log of 2/3. Okay, so here this simplifies to 1. And we get x equals to log 3 over log 2/3. All right. And we can just leave it like this, right? The last step would be plug it into our calculator, but this is what I'll be looking for, right? This, that you're able to work through this equation one step at a time, at each step showing your work. Okay, all right, so this is sufficient enough, right? These are just numbers, right? actually the least interesting part of this problem is just plugging that into the calculator. All this use of our logs and log e properties is what I am looking for in your solutions. All right, let's try one more example, right, where we could see that, again, we have to do some manipulation beforehand to get it to where we can take the log of both sides, right? So let's say that we're asked to solve this 3 times 2 to the negative x is equal to 6 to the 3x. All right. Now, at first glance, we're like, well, this doesn't look anything at all like what I have seen before. All right. So what we can do from here is we can say, all right, well, let's we can take the log here from both sides. We can do right away. We can say, all right, let's see. What if I take the log here, 3 times 2 to the negative x, log 6 to the 3x. So at this point, it doesn't look like I can just I can't use the power rule here just yet, because this would have to be the power to both of these terms, and it is not, right? But the log does have these product rule that allows me to do this, right? I could split this up as log 3 plus log 2 to the negative x, right? And similar to before, the log was a common logarithm base 10. All right, now here I can use the power rule, right? I just have one base, so it'll be 3x log of 6. All right, now we're getting somewhere, right? Now we say, all right, well, from here, what we can do is okay, so from here what we can do is I'm going to apply the power rule here. So this now becomes log 3 minus x log 2 equals to 3x log 6. All right. Okay. Now I'm going to do the same thing as before. I want to get my values of x all on one side of the equation. So to do that, what I'm going to do here is I'm going to add x log 2 plus x log 2. Okay. So now this goes to 0, and we have log 3 here. And on this side, we'll have 3x log 6 plus x log 2. All right. And then again, similar to before, we'll factor out a x here. All right. And then let's condense this. So what this will become is log 3 is equal to x log 6 cubed, right? It's a power rule. So this becomes 3 is the exponent here, and then here times 2. All right, and then divide both sides by whatever this value is, and we get so that becomes 1, and we get x is equal to log 3 over log 6 cubed times 2. Parentheses there to make it clear that both of those go into the argument of the log, right? And again, right, least important part, whatever this value is, right? One thing that I do want to remind you is this is not a quotient rule, right? So do not, I know it's tempting to say you see a quotient, you're like, oh, I can apply the quotient rule to logarithms. This is not a logarithm quotient rule. Remember, the quotient rule applies when the quotient is inside the argument of the logarithm, okay? Not here, okay? All right, so that is how you use logarithms to solve these equations.